So this topic we're going to look at something called electrolysis. Electrolysis is the splitting up of compounds to make elements using electricity. So we're going to be literally, electro means electricity, lysis means splitting. Let's have a look at how that works. So first thing I need a beaker of something that can be electrolyzed, and the way that this works is relying on the idea of the particles being charged. So something with charged particles must be ionic in its nature. So ionic substances are the things that we're going to electrolyze. So if I have a beaker of an ionic substance which is dissolved in water or liquid, and I put some electrodes, sticks of graphite, in, and I put a circuit on it, and I switch the circuit on. That's literally it. That's what's happened. That's all that's going to happen. It will work. I can just produce elements from this compound just like that. So a couple of key words. The electrolyte is the ionic substance that we are electrolyzing, that we're splitting up. We have two words here for the electrodes. The negative one we call a cathode, and the positive one we call an anode. Now, you'll remember that ionic particles, when they're solid, the ions in the solid cannot move. Okay, so that's why we need a liquid or a solution. And the reason it has to be ionic is because actually the positive and negative ions are attracted to the electrodes. If this was covalent, that wouldn't happen and this wouldn't work. So we're going to attract the positive ions to the negative electrode and the negative ions to the positive electrode. Now, just to be aware, the cathode, the negative electrode, attracts the positive particles, and therefore the positive particles are called cations. And the anode attracts the negative particles, and we call the negative particles anions. So cations are attracted to the cathode, anions are attracted to the anode. And so when we turn the power on, we will see that we separate out our positive from our negative. And then a chemical reaction is going to happen. They don't stay as positive ions once they get to the electrode, they neutralize. And we'll look at how that happens in another video. But the same on the negative side. The negative ions neutralize when they get to the positive electrode, the anode, and we end up with elements forming at both of the electrodes. Now, if I had copper chloride, for example, the copper would be the positive because it's a metal, and I would see on my electrode a layer of brownish pink copper forming on the electrode, and I would see on the other side the chlorine, the non-metal, the negative particle. I would see bubbles of chlorine gas forming. So, ionic substances conduct electricity in liquid and dissolved states. Positive ions are attracted to the negative electrode. Negative ions are attracted to the positive electrode, and there are some key words that we need to learn. And our chemical reaction is going to turn our ions into elements. So here's some examples here. Lead ions turning into lead atoms, copper ions turning into copper atoms, chloride ions turning into chlorine molecules, and oxide ions turning into oxygen molecules. You remember that chlorine gas goes around as Cl2, and oxygen gas goes around as O2. So we are forming molecules rather than atoms. Let's just look at one more example, molten magnesium bromide. So you're asked what happens when molten magnesium bromide is electrolyzed. Well, your molten magnesium bromide is split up into its ions. So we've got magnesium, which is 2+. We can find that from the periodic table. And bromide is Br-, again it's in group 7 from the periodic table, we can work that out. And we are going to change the magnesium ions into atoms of magnesium metal, and we're going to change the Br-, that's in group 7, so it will go around in pairs, so it will be Br2. And that's it. Our magnesium bromide is split up into its elements.